represent Gardner, who supplied the equipment. Okay, and also I assume did the startup and okay. You're the proud owners of 8 rooftop units, 3 different styles. You have 2 RPSs, which are the largest tonnage. One of them being 63 tons and one is 50. Then you have several MPSs, which range in tonnage down to 30. And then there's a couple of what they call Rebels, which are DPSs, which are smaller tonnage. Okay. What I thought I'd start with is just take a peek at a couple of the submittals that show what you bought. The reason I'm saying that is because they have pretty nice pictures that show where things are. Okay, and if you've never gone up and peeked at them, I'm trying to prep you so we don't have to spend as much time on the roof as possible because it's a little chilly up there. All right, every one of these units has the same configuration except for 2 of them. They're all VAB. They all have an energy recovery wheel. They all have hot gas reheat. They all have gas reheat. And they're all backnet controlled or backnet monitored by your automation system. 7 and 8 have CO2 sensors. If you don't know what that is, that's a way to measure stale air, and it will adjust its outside air intake based on set points that are pre-programmed into the machine. So kind of keeps the children from falling asleep. They all have regular filter setup, decent warranty on everything, first year parts and labor, 5-year compressor warranty, and 10 years on the heat exchanger. So this happens to be RTU1. Okay, you've got a condensing section over here where the refrigeration system is. You've got a heating section here where your heat exchanger is shown. This is your supply fan. This is the DX cooling coil and the hot gas reheat coil, which we'll talk about. You've got a set of economizer dampers that decide outside air, return air combination, okay? And you've got your heat wheel here. Are you guys familiar at all with the heat wheel?
No.
Okay, what heat wheels do, they're an energy saving device, okay? Because typically in schools you have some pretty decent requirements for outdoor air, you're going to be bringing in quite a bit. Well, you paid money to condition what's in the space. So what the heat wheel does, and I'll have a better picture of it down the road here, is it actually takes the air you're exhausting, passes it over the wheel, that wheel absorbs that heat, or cooling depending on the season, and passes it to the entering outside air. There's a significant energy savings there, and they're pretty much trouble-free as long as you keep it clean. Okay, that's the key with heat wheels, they have to be kept clean. There's additional filtration to protect that heat wheel, which makes changing filters a little bit more than the normal. We're just going to put one set of filters in. There's several sets, okay? But if you keep it clean, there's really not a whole lot to do with it. Depending on how your automation system monitors, you have graphics on the automation system.
Yes.
They will show what the heat wheel's doing. You can actually look at the heat wheel performance based on temperatures entering and leaving. So what the heat wheel does is as it spins slowly, you're moving temperature from here to here. It's usually up and down configuration as far as the ductwork. If you get to a point where you have to clean it, they are washable.
So you take a hose up there and you just hose it up?
The larger ones you actually have to pull the pieces out of, okay? My recommendation, and I've seen this happen in another school system, is don't let them get plugged. It's a monumental job to clean them if they get that bad, okay? Generally, you can vacuum them off if they get a little surface dust, and then you can clean them with water.
How often does it have to be done?
That's going to depend on where you are, the amount of run time. Everything's variable. The same with your filter intervals. Everybody asks me how often should we change filters. That's going to depend on usage. It's going to depend on occupied hours, the whole thing. I would suggest you start tracking, okay? One of the things I tell people in a new building like this is you just need to get to know it. You get to know the characteristics of your machines, the sights, the sounds, and you'll figure out pretty quick how fast certain units load up filters compared to others. I'm going to guess the admin areas aren't going to be quite as maintenance, strict as much as where a lot of students are moving around. That's what makes the dirt. If you're seeing filter plug alarms, which I thought I heard you say there's something on here, either on board the unit or in your control system added, that would tell you the pressure drop across a set of filters, okay?
So that will let you know.
Now, being that they're VAV, and you guys know what VAV is, it's variable air volume, it changes based on the need of the space, you're gonna have to get the hang of that pressure drop if you're not gonna be going by a number per se, because the less air, the less pressure drop you're gonna see across a set of filters. It's most critical when the machine's running at a pretty decent load. That's when you should see the larger pressure drops on dirty filters, okay? It looks like you've got, I don't know what the MERV number is on the filters, but they're all probably the Z-style filters. And when we get up there, we'll yank some, and basically I hold them up to light. Sometimes they look really dirty, but because they load up very evenly, if you can see light through them, they're still okay.
Do we purchase those through you guys, or do we purchase them through?
Pardon me?
Do we purchase them through Gardner, or?
You can purchase them wherever you want, okay? Gardner sells them, but I'm not here to sell you
No, I
anything. There's a lot of filter suppliers out there, and some school systems have a purchasing system that ties you to certain places, okay?
You got 2 sets coming here in another couple of weeks, actually. I think the ones are back ordered.
Okay,
They have your mill, but you'll have 2 late sets coming.
okay.
This is just another pictorial of the outside of the unit, okay? As you can see, this is going to be the outside air intake over the top of the wheel. This will be the exhaust that's going to come over the bottom of the wheel. That's how they exchange the temperature, okay? I know on many of the Daikin units, there are some washable screens on here. We'll see those if we get upstairs. Those have to be pulled out and hosed. And they're going to catch the rocks in the bottles, you know, the big stuff, leaves and things over time. But again, they'll load up based on how much outside air you're bringing in, okay? Let's see if I can get to an RPS here. That's a smaller one. This is the DPS. They call them, I think they call them a Rebel. Okay, it has all the same options. It's just smaller tonnage. So the footprint's smaller and everything's crunched together a little bit. I'll show you. Let's see. You see how everything's a little more compact in there? Okay. There's adequate amount of doors for you to access anything you need to look at, okay? This one would have, the smaller one has a direct drive fan, okay? And so there's no belt. The wheel's right on the fan itself, okay?
Okay, this is unit number 3. Is there 2 units that are exactly like this on the roof?
RTU 3 is a DPS 020, and then RTU 4 is a DPS 018, which is just slightly smaller in capacity. Yeah, 3 and 4 are, for all practical purposes, except for some BTUs, almost identical.
And there's no belts in this. Number 3 and number 4, there's no belts.
Doesn't appear to be, no. It's
Okay.
direct drive, okay? Only the larger units have belt drive, okay? And when we get upstairs, if we look at a larger one, we're going to talk a little bit about lubrication, okay? Most of the fan bearings are lubricatable. Not all the motors are. Every motor manufacturer is different. Some come with Zerk fittings, some don't. If they don't have Zerk fittings, they're seal bearings, okay? If they do, you need to grease them. And they were probably greased at startup, okay? The number is 2,000 hours, but that's again going to be based on how much you use the machine. Over-greasing can be as bad as not greasing, okay? I would suggest you pull the drain plugs when you grease and purge it out. That way you don't pressurize the chamber and spew the grease out into the motor. You don't know that's happening. It's just, there's no place for that pressure to go. Grease guns can make a lot of pressure, okay? So we'll see that when we get up there. I have no way of knowing what's greasable it isn't until we get our eyes on it. Okay. This is an RPS. This is a 50-tonner. You see the footprint's somewhat bigger. Were these rigged in one piece?
Yes.
Okay, good, because sometimes they break them down on the larger tonnage. Okay, we'll look at, okay, this particular one has 3 compressors, 2 fixed speed and 1 variable speed compressor, okay? These are all controlled by the microprocessor as far as when one comes on, when the other comes on, and what changes the speed of the variable speed compressor, okay? Right, so here's the footprint of the larger RPSs, the two you have. You see it's spread out. You see the exhaust fan is a big belt drive fan, large heat wheel, then filter bank, supply fan, heating section. This is the DX cooling, and this is the hot gas reheat. Now, let's take a minute and talk about hot gas reheat and why it's there, okay? These machines sense, I believe it's return air humidity in your space, okay? One of the situations that is prevalent, has been prevalent in schools for years, is you don't load a classroom like, it's designed, and the cooling doesn't have to run very much for it to get to set point, and it gets humid in there. It gets like damp. These machines will dehumidify based on the return air humidity. So you could see heating and cooling running at the same time. So what they do to save energy is they divert some of the hot gas from the refrigeration system that they're dehumidifying with into a reheat coil that's downstream of everything. So it raises the discharge temperature on the machine, saves some energy, you don't have to run the gas heat, and they all have this.
So you're saying that in the summertime, when the air is running, and the dehumidifier is going, it's not uncommon to see the boilers firing up?
You shouldn't need the heat running if there's hot gas reheat available. So what it'll do is automatically divert some of the hot gas from the condenser to be expelled to the airstream to add heat.
Okay, so the hot gas is coming from the condenser?
It's come from your compressors.
Compressors, okay.
Yeah.
It's all self-contained.
Yes. And it, again, I keep talking about the microprocessor. It controls all of that. It controls the diverting valves, it controls the temperatures.
Yeah, I just was thinking that the hot gases will be coming from the boiler and making...
No, this is,
Okay.
you probably only see the gas heat run during the winter,
Okay.
because you've got hot gas reheat, right?
So, and then you have belts on the exhaust fan and belts on the
Supply fan, right, and
On the bigger unit.
yes. We're gonna grab one of those or two up on the roof and we'll take a peek at them, okay? So that's, everybody kind of understand how hot gas reheat works, okay? Now, I don't know how deep your guys gonna get into this stuff. If you're strictly maintenance and operation, you'll never have to worry about that. You'll probably be first responders who say, something's wrong, I gotta call somebody. This is the controller that's common to all of your machines. It's called a Microtech 3. It's been around with Daikin forever. They use this same control platform on a lot of their products, whether it be a chiller, a rooftop, or whatever. It's just programmed and software is put into it to match the application you have, okay? It's a simple screen. It's got some dials that let you go up and down on the menu. But to answer your question, anything that except, I'm pretty sure, for phase failure, where your power in the building isn't right, it's going to show up as an alarm on this screen. And the alarm they'll be flashing, you hit that button, it'll take you to the alarm. You can reset an alarm without entering any passwords. It's that simple. And my rule of thumb is, reset once. If it's an anomaly, if it was caused by something strange, if you have to reset it again, it's time to make that phone call. Sure. One of the things that Daikin does, as opposed to some other manufacturers, it stages things up sequentially and slowly, okay? So you hit that switch, it's not gonna bam right on. The first delay you're gonna see is probably a 60-second delay for the power relay that monitors your three-phase to come back, okay? After that, things happen kind of quick, but I'll show you, because there's LED indicators on all of these machines. See these things? Okay? There's green and yellow, or in some cases they turn red. They tell you if it's communicating with all the other modules. They tell you if there's an alarm. All kinds. There's a lot you can learn just from looking at the LEDs. And I want to show you something here. These, just watch as I scroll. Those are all the configuration set points in this controller. So you can kind of understand why it's best not to mess with them, okay? It should be documented how they set it up. Did you have a commissioning agent on the job?
Yes.
I'm sure they verified that they're set up exactly the way they're supposed to be. You should never have to go that far down. And the problem here is it's such a sophisticated control. You change this, now
It would fit
3 other
something
things
else.
over here need to be changed, so everything aligns. So you just don't want to, okay? All right, I just wanted to give you an idea. As we go up there, you're gonna see that this is what the thing looks like. Right here, come on. So there'll be modules tied to this. Everything on the left side is external communication. So there'll be a backnet module on the left side of this tied to your automation system. You'll know it's communicating because the little light will be green. Everything on the right side is onboard communication on that machine because it uses modules for the expansion valves, modules for the condenser fans, modules for whatever, the valves that switch to hot gas reheat. All of those have to be green or it's not going to like it, okay? And we'll see that. We'll watch how that happens upstairs. So everything on the right's internal, anything on the left is external, okay? If your automation system is doing primarily monitoring and scheduling, then they're going to be at whatever they were set up per the submittals internal to that controller. And they should all be the same, okay? There's only a couple ways you can order this program for a rooftop. 3 configurations, okay? VAV, then there's, what do they call it? Single zone VAV, and there's one other. These are all set up for VAV, okay? And so when you do that, the set points become like canned, what's typical, okay? The only reason you need to change them if there was something strange about the space that just wasn't normal, okay? And you don't know that until after your thing's run, okay? Maintenance, they talk about planned maintenance, okay? And they list the things you should check on planned maintenance. Some of those things would be outside your scope of what you guys do on a normal basis, okay? But just to run down them, right? Tighten belts, connections and set screws, okay? So obviously you're gonna look at the belt, you're gonna see if it's slipping, you're gonna look at the shivs and see if they're glazed or shiny because the belt's been slipping. They want you to check the set screws on the bearings, on the fans, to make sure they haven't come loose. I'm sure you guys have seen what happens if a bearing spins on a shaft, just kind of eats the shaft, okay? Let's see, lubricate motors and bearings, we talked about that. Align and replace belts, clean and replace filters. You're not gonna mess with the refrigerant charge. How many of you guys looked at refrigeration systems in the past at all?
What do you mean look at them?
I mean, have you seen a sight glass? They have, don't pay attention to it. We'll get to why, but in a lot of cases, the sight glass will show bubbles, okay? It's just by design. And the reason it is because of the new design of condenser coils, okay? Superheat, subcooling, you're not gonna check that. Motors and amperages, that's, you know, I don't know. Some school systems have electricians who would do that. The thing I would recommend from an electrical standpoint, once a year or twice a year, shut it down, open the panel, and just look, okay? All the connections should have been tightened and checked at startup, but over time, temperature changes, vibration, things get loose, and you're looking for those green connections, the overheated connections. If you catch those soon, you won't have to replace components, okay? Because once you start overheating of a starter or a breaker, it gets expensive, and you have downtime, okay? You're not gonna run it through its cases and check all the safeties. That would be if you have a contract with somebody, they would do that. Propeller fans, which would be your condenser fan motors, put up a ladder, go up there and make sure nothing looks like it's loose. The blades aren't cracked or anything like that. I can tell you I have, before I retired from Gardner, we had been Daikin reps for almost 3 years, and I don't think we ever changed a condenser plant blade because it broke. Okay. What else does it talk about? They talks about a little bit of the refrigerant piping. You know, if you look at the refrigerant condensing section, you see oil or something that doesn't look right, make the phone call, okay? So here's the condenser coil. These are called micro-channel coils. Okay, if you've ever seen condensing coils like on a residential unit, they're just a coil with tubes running through them. They are no more. Almost every manufacturer's moved to micro-channel. And you can see in that diagram, and it kind of shows, it's like a car radiator. Very little space between very high heat transfer, and because of that, they don't hold refrigerant. The older condenser coils, you can overcharge them and the refrigerant would back up. There's so little ability to log refrigerant, it just fills up, and you need to go off on head pressure because there's no place for the refrigerant to go, okay? When you clean them, if you have a power washer, throw it away. You don't want a power washer. You don't want caustic chemicals, acids or anything. Water, but first a brush or a shop vac. If he gets an army blanket on it, like I call it, just brush it off and then hose it, okay, with just water. If for some reason you get something noxious on it, the only thing I would use is Simple Green. It doesn't need anything. You can buy it at Home Depot, okay, or something of that nature. They have a whole section in there that talks about coated coils. Well, we're not by the ocean. You don't have coated coils. There's a whole group of cleaners that they want used on those because there's more corrosiveness. In your case, the garden hose. But it goes back to the same thing. Stay ahead of them. It's designed to shed water. It's outside. Okay. So there's nothing you're going to do on that condensing section that's going to get water into your building. Just to give you a heads up, during the summer, Gardner has 8 people full-time washing condenser coils all summer. And they have on their books probably 8,000 hours of condenser coil cleaning. So there's a lot of air-cooled stuff out there now. People have gone from, 20 years ago, this building would have had a chiller and air handlers. Now it's all gone to unitary. It's cost, effective, efficiency, so it's just the nature of it. A lot of coils to clean, okay? So any questions on the condenser coils? All your units have microchannel coils. Some of them are going to look a little different, but they all have microchannel coils. They're aluminum, so don't beat on them. They're kind of fragile, but they're well protected within the unit.
So you want high pressure water, just stick a hose.
Just the garden hose is all you should. You can buy one of those tips that shoots straight. That is, city water pressure is what, 40, 45 pounds. You can't, you know what I mean? But if you don't wash the dirt through, you'll never have to worry about going on the inside and washing it back out. Okay, so try to wash it downward. Okay, after you get rid of the big stuff. They talk a little bit about electrical components. That's a typical overload starter, contactor for a fan or a motor or something. Again, look for electrical connections, look for overheating, okay? I'll go back to what I said before. You can learn a lot just looking. That's what you guys do, you look, you get to hear. You cannot open that with the power on. It won't let you, okay? There's probably a way to defeat it, or maybe with that little screwdriver there, but I can't tell you to do that because you have your own safety rules here, okay? That's pretty much the recommended maintenance. Now, somewhere on one of these, and we'll look at it upstairs, there is one of those maintenance things shows what you do to a heat wheel. You know what I mean? How to pull it apart and everything, which you just don't want to have to end up doing. But we'll look upstairs. It's pretty simple, okay? Very complicated machines, but in my world, I believe they're pretty user-friendly when it comes to just doing maintenance on them, okay? Have you seen the doors and everything on them? There's different types of doors on different units. Some have one kind of latch, some have a screwdriver. They're not bad to use, okay?